All right, here we go. We're going to talk about Active Directory today and what it is and why it's useful. So why do we need Active Directory? I'm going to use AD for Active Directory quite a bit. It's a lot easier to just say AD than Active Directory. So let's go back in time a little bit here. Active Directory was released with Windows 2000, which was released in 1999. At that point, you had a lot of personal computers. Personal computers had taken over, and all these personal computers had individual logins on them. But people needed to share computer resources more and more, especially as networking, fast Ethernet networking started to become available. And mainframes, with their central login systems, they weren't being used as much anymore. This is a big change from both 70s and early 80s, where mainframes were used quite extensively. And you had some central authentication systems, such as Novell NetWare, that existed in the 80s and 90s that allowed you to do some sort of resource sharing and specifically authentication sharing, but it didn't really take off. So, Microsoft said there was a need here for a service where we can create accounts, whether that is a user account or some other account, in one central storage location, and then use that central storage area to authenticate um, users or computers or whatever resources that we have so that they can work together. And therefore, Active Directory was born. So let's define what Active Directory is a little bit here. Here are the SLOs that you'll be able to cover. You'll be able to identify and describe the basic software services that make up Active Directory. You'll be able to describe the function of Kerberos, and be able to describe the basic LDAP distinguished names for organization units, groups, and users. So Active Directory Domain Services, otherwise known as ADDS, stores directory data and manages communications between users and domains, including user login processes, authentication, and directory services. So that's just a quote here about what we're talking about. There's two things we need to be able to define here. We need to be able to define what a domain is and what a site is. So let's just start defining them. A domain is a group of computers that share a common directory database. And a domain provides logical structure for our computers that work together. So kind of think of just, let's say I have a group of computers. I'm going to get them all to work together. They all belong to one organization. It doesn't matter if that organization is one building or one campus or five campuses or global, doesn't matter. But they logically, all these computers need to work together and they want to share resources such as authentication, computer resources, file shares, printers, etc., etc. That domain will provide the logical structure. We also have a site, which is a group of computers in one or more IP subnets. So this is going back to TCP/IP and IPv4, and you have a set of subnets. So usually a subnet is defined as on top of a layer 2 network, which is more tightly defined in a geographic location, and we can bind together one or more of these IP subnets together into a site, and this provides us with physical structure. So if I have a domain that is worldwide, for a company, the logical organization is going to be the domain. Within that company, I might have a site in Grand Rapids, I might have a site in Chicago, I might have a site in London, etc. And those will all be distinct IP subnets that are within there. So, domains. What do they store? How do they run? How do the computers talk? And how are things organized? Well, what are the items that are stored in a domain? Let's start with just the basics here. These are called security principles. In our domain, we store users, specifically user accounts. My user account is CS339. That would be my user account. It's my username. That's stored in there. I have computers. What computers are in there? Each computer has a intrinsic um, computer account that it can use to log into our domain. And I have groups, which are groupings of things such as users or computers together. It allows me to do permissions and stuff like that on a group rather than on individual people. I also have resources, printers you might see in domains, group policies, which are like security policies or configuration policies on a computer. That might be stored in a domain. Um, where do these things get stored? Well, in order to have a domain, we have to run domain controllers. And this is something that Microsoft provides as software, and you install it on a Windows server. So a domain controller is any computer that runs the Active Directory domain services or the ADDS services. It's the domain controller's job to store that domain database. And it's the domain controller's job to authenticate users. That's whether or not I have a valid password or not. And authorize users. That's whether I'm allowed to use a service or not, both users and computers. And it's up to the domain controller to assign and enforce security policies that I might have in my domain. In a typical Active Directory setup, you're going to have multiple domain controllers. Active Directory operates in this multi-master replication model, which means I'm going to have more than one server. They are all authoritative, they are all masters, and that they will send changes, they will replicate changes between them all automatically and keep everything in sync. Any domain controller that is set up in read-write mode, which is I can read and write, can process any directory change whatsoever and automatically replicate them to other domain controllers. Why do I do this? Well, these days it's not as big of a deal, but think back, 1999, high-speed internet links were expensive. If I had a lot of authentication data or I had a lot of domain data that had to go over the wire, that's a big deal. So, and latency is not that great. So, if I had my domain controllers in Chicago and I'm logging in London, ooh, not great. That's a lot of data that has to travel overseas back and forth. But I could put a domain controller in London. Once it replicated everything, my local computers in a site in London could talk to the domain controller in that site, and I would only have to replicate the changes between my domain controllers between Chicago and London, for example. With domain controllers, I can also set up read-only domain controllers as well. These are typically used for like last mile caching and stuff like that. I can have a domain controller out in the cloud. I can have a domain controller running in an office in read-only mode. Anytime I have to make a change, then your traffic gets routed to the central offices, but any reads, logins, etc., can just come locally as well. So when we decide to do authentication in Active Directory, we never send a password over the wire. We use something called Kerberos for authentication, and Active Directory actually runs a version of LDAP, which is a standards-based directory service for my directory. Additionally, Active Directory utilizes public DNS, that is name resolution, so www.google.com to an IP address. DNS is integrated within Active Directory so that I can look up where these services are, specifically like where my LDAP server is within Active Directory. And I can manage all of my services and service records using the built-in DNS system within Active Directory. An Active Directory domain controller will be required to run a DNS server as well. And we'll talk more about DNS here in a week or two. Okay, so how is Active Directory actually organized and arranged? Well, Here are the SLOs that we need to cover here. Students will be able to describe the basic layout of Active Directory. Students will be able to describe the default OUs within Active Directory. OUs is organizational units. We'll get into that in a minute. Students will be able to describe the object types that exist and describe the basic LDAP distinguished names for organization units, groups, and users. So, OUs, organization units. These are folders when it comes to LDAP. These are logical containers that we can organize things in. They are pretty simple. They are an organizational tool to help with management. 80 ships with a bunch of default organizations, but we can make our own to do whatever logical or organization that we want to within our domain or in our directory. By default, Active Directory will come with lots of default OUs, such as built-in computers, domain controllers, system, users, etc. But we can add more as we go. And I'm going to just briefly show you a Active Directory system. This is the computer science Active Directory system, and I'll show you some of these default OUs that we have in here as well. So this is a remote connection to one of my management stations that is running running my Active Directory domain controller stuff. You'll notice that in here, inside of here, I have lots of different, this is my domain, csad.cs.calvin.edu, and I have lots of built-in organizational units such as built-in computers, domain controllers, system, users, etc. So these are default ones. I have also added several more for my own logical management, such as CPSC or computer science computers. And then within there, I have other organizational units, such as servers, which have my file servers and other servers in it. Lab machines, such as the gold and maroon lab machines. They all have computer accounts in here as well. And other organizational units like groups and users. And within users, I have CS338 and 339 users. So you might find your user account in this list. So it's an organizational way of organizing my Active Directory. So when I do my organization, I have to follow the rules of LDAP when that happens. So it requires that all directory objects be formed according to a couple of RFCs, which define the standard for object names. Every object in Active Directory will have a full object path, which is called a distinguished name or a DN. So distinguished name. It is a unique path-based way of addressing an object in Active Directory, or within LDAP, I should say specifically. DNs are unambiguous. They identify one object only, and they're unique. There's no other object in the directory that has this name. The full path of the distinguished name includes the object name and all parent objects to the root of the directory. And you're kind of saying, okay, what does that look like? Well, let's look into this. In a distinguished name, we are going to have several different attributes that we are going to need to refer to. We've talked about our domain already. This is our big logical organization, and we will have a root domain name that we'll have to use to build up our distinguished name. We've talked about organizational units, or those folders that stuff is put into. And specifically for our DN, I'm going to focus on user accounts here. So I'm going to have a user object. For LDAP, I have a couple of different names that these refer to. Common name for user is a CN. Organizational unit name is commonly referred to as an OU, which we've already discussed. And a domain component is labeled a DC. So let's take a look at an example for this. I'm going to build up a distinguished name starting from the root of my domain. For this one, I'm going to use a fake domain called noam.reskit.com. And how do I make the domain portion of the distinguished name? Well, I have to actually split out the three sections of my domain into three separate domain components. First, the noam, and that'll be referred to as DC equals noam. Second, the reskit, DC equals reskit, and com, DC equals com. I string them all together with commas, and my full distinguished name for my root of my Active Directory domain is now DC equals noam, comma, DC equals reskit, DC equals com. So let's take the csad.cs.calvin.edu domain. What is my base distinguished name or my base DN for that? Well, I'm going to split all these into domain components and add commas between them. So DC equals CSAD, DC equals CS, DC equals Calvin, DC equals EDU. Calvin's main Active Directory is ad.calvin.edu. And in order to split that one up, it would be DC equals AD, DC equals Calvin, DC equals EDU. So let's look at our user John Smith here, J. Smith. John Smith happens to work for the promotions department, which is a member of the marketing group in our noam reskit com domain. So I have two organizational units folders that are doing logical grouping for me, the marketing one and the promotions one. How do I do this? Well, I work from the inside out and I label each component. So common name, we saw that was referred to as CN. Common name J Smith. So CN equals J Smith, comma, organizational unit of promotion, so OU equals promotions, organizational unit marketing, OU equals marketing, domain component, noam, and we already talked about the domain component stuff, so I just put it on there, noam DC reskit. So this is our full distinguished name for John Smith in this particular directory. We used all three of our LDAP naming attributes. Now there's more than this, just these are the three that I want to focus on. Our common name, CN equals J Smith, our organizational unit, OU, promotions, OU marketing, and then our domain component or the DCs. So going back to our fake directory, noam.reskit.com, what would be the full DN for Clark Kent, who works in the finance division in the payroll office? So as we were doing this before, we had marketing before. Payroll is our finance is going to be my division. That's going to be the broadest one. Payroll is going to be an office within the division. That's more specific. So I'll have my domain on the right, followed by finance as my division, OU equals finance, OU equals payroll, and finally CN for Clark Kent, C. Kent. And that would be my full distinguished name. Now, what if there was also a Clark Kent in the accounts payable office? If I had an organizational unit for this other Clark Kent in accounts payable, I could have another unique, unambiguous CN that would refer to a different account, but it would be CN equals C Kent, OU equals accounts payable, not payroll, OU equals finance, etc. It is possible to have two accounts name the same exact thing in Active Directory. It's highly not recommended that you do so, but it is possible to do it. And there's actually hundreds of attributes that you can query or use to select an object. LDAP searches can be performed on one or more attributes to find objects in are in our LDAP server. And Microsoft has a great tool for this called ADSI-Edit. And there's all kinds of things that you can search for: UID, surname, SN, given name, that will be like a first name, mail, telephone number, etc. And let me see if I can pull that up for you a second. All right, this is the ADSI-Edit tool, and I've already gone into it and opened up our domain, which is the csad.cs.com.edu. So notice how it uses the distinguished name here, DC equals CSAD, etc. And then I have a couple of built-in OUs, and I'm going to drill down to our OU computer science users, OU generic users, and look at CN computer science guest. Now this is a account that I have on the machine, and I have lots of other properties that I can look at too. So if I go to my properties list here, you'll notice that in this list I have lots of different properties: account expiration, audio stuff, codes, departments, employee ID, etc., etc., etc. A lot of this stuff just isn't set. So I have the ability to actually filter this stuff. Let's only show the stuff that has values. So things like, the country code where I'm at, which isn't filled in. My GUIDs, my object GUIDs, these get to be important later on in the SIDs as well. And full things like my user principal name, which kind of looks like a email address, but it actually is the user account at the domain in question here. So lots of other things that we can get at if we actually dig into LDAP and into the individual accounts. And we can use that when we do our searches to actually find specific things, like find all the people that have this email address, for example. So we talked about LDAP, and we talked about how the distinguished names work. But the nice thing that AD is used for a lot of times is authorization. Who is authorized to do certain things? Who's authorized to use one service? Who isn't authorized to use one service? So we can do some filtering when we are doing some of this stuff to match different flags on our user account. So one of the ways we could do this is we could set an attribute on these LDAP field, or on these LDAP user accounts. So let's say I set an LDAP a flag, an attribute, that security flag 1 is equal to admin, for example. This might be user or whatever. My application can look through my user account, match any admins that have the security flag 1 equal to admin, and then give that person additional rights in the system. So that's one way it can be used. So LDAP is it's a very nice system. It is an open source layout. There are different open source LDAP systems out there, but Active Directory utilizes LDAP to store a lot of its attributes and a lot of its user accounts and things like that. So now we're going to move on to authentication. How does Kerberos do authentication within Active Directory? So you should be able to describe the function of Kerberos within Active Directory and how Kerberos authenticates users over insecure mediums securely. So basically, how can we do this over a public internet connection, for example? So Kerberos is a network authentication protocol designed to provide strong authentication for client-server applications using secret key cryptography. Active Directory, as part of its suite of services that it runs, is going to run a Kerberos server that provides an authentication server, otherwise commonly known as an AS, and a ticket granting server, otherwise known as a TGS. Services that use authentication have to register within the Kerberos server. Any user that wants to use a service that's registered within Kerberos must obtain what is called a service ticket from the Kerberos Key Distribution Center, or the KDC, to gain access. So, for example, a lot of us go to websites, and when you're trying to log into like your Kelvin email, for example, Office 365, you type in your username, it forwards you to another page, a single sign-on website, where you can put in your credentials, and away you go. In order for me to use that single sign-on stuff, I'm going to get an HTTP ticket for that single sign-on service from the Kerberos Distribution Center, the KDC. So this is kind of a high-level overview, and I'll kind of give you what is going on here. So let's say you, the user, are sitting at a computer and you are trying to log into said computer. You are going to send a request from your computer to the Kerberos server, which is called an AS request. And I think that's authentication service request to the authentication server. And AS response is going to actually give you a encrypted response back. And what it's going to be doing here is it's actually going to be sending you something that is encrypted with your password. If I have encrypted something with my password, I don't have to actually send my password over the wire. If I have the correct password over here in my client, I will be able to decrypt what came from the authentication server, which is going to kind of be like an authentication token. I can then encrypt a ticket granting request with that authorization token that I just got, send that over the wire to the ticket granting server, which will then look at that authentication token that I got and say, yeah, you're good to go. Here's a ticket for you, which then I can send to the different services, request to each of the services. So the big thing to realize here, though, is when I make a request to the authentication server, all I have to do is send, I would like to authenticate, and here's my user account, just my username. That's all. The authentication server will say, okay, if you are who you say you are, I'm going to encrypt a response and also a ticket that you can give to the ticket granting server. I'm going to encrypt those with your password, with the knowledge of if you can decrypt it over on the other side, you'll be able to use that ticket in order to continue on the Kerberos process. If I make a request and I don't have the password over here, or I type it wrong, I won't be able to decrypt what got sent to me, and I won't be able to take any further steps in the Kerberos process. So the big deal here is never do I ever send my password across the wire anytime I'm using Kerberos, which is a big difference from a lot of other authentication methods that are out there. Oh, so you have all these different user keys, you have these ticket granting tickets, session keys, etc. There is a lot of different things involved in the Kerberos process. I'm not expecting you to get into all these things here. Just realize that you have to get the appropriate keys and you have to have the appropriate tickets in order to use the services at the various spots. And a lot of times, one of the reasons that I say I don't really care that you know all that stuff is because most of the time Kerberos just works. It works 99% of the time. It just works, and it works great. But occasionally, as a system administrator, you will have to find that you're trying to do a custom service and you have to manually register your service within Kerberos using a Windows Service Principal in order to get things working. Again, 99% of the time, it just works. All right, so more advanced Active Directory things. Within Active Directory, there are 3 operation masters, and you should be able to know what those are and what they do. You should be able to define what a tree and a forest is. You should be able to define what Active Directory schema is and the importance of it. And you should be able to define what a global catalog server is in Active Directory. So within Active Directory, we've talked about all the services that it's running. It's running DNS, it's running LDAP, it's running a Kerberos service. There also are 3 operation masters that have to run in a domain, and these operation masters run on only one domain controller within a domain. The 3 of them are the RID master, which the relative identifier operations master, it allocates blocks of RIDs to the domain controllers in a domain. When a domain controller creates a new security principal, such as a user, a group, or a computer object, it has to assign a unique security identifier, otherwise known as a SID, to that thing. And that SID consists of the domain SID, which is predefined, and the RID, which uniquely identifies the security principal within the domain. So they're kind of combined together. And if I go back to my thing here and show you a little bit of my guests here, you'll notice that I have a GUID here, which just looks like a whole bunch of alphanumeric values with hyphens. And then I also have a SID, which is pretty much the same sort of thing, although I think these are all numeric as well. So it's the RID master's job in order to kind of give the domain controllers their blocks that they can hand out, so that we don't have any intersection or accidental collisions within the domain. The PDC emulator is a function that receives preferential replication of password changes that are performed in domain controllers. And this particular PDC emulator is always the authoritative source for the latest password information whenever a login attempt fails because of a bad password. It also is used for group policy and distributed file systems, as well as the authoritative source. So while our multi-master mode works very well, occasionally you just have to have one server that is if something's in error, I need to be the person that says this is how things are. And that's what the PDC emulator does. So when a password change happens, it goes to the PDC emulator first, which then replicates down to all of the other domain controllers. And lastly, we have an infrastructure master, which it basically is responsible for updating object references in the domain that point to an object in another domain. And that leads into the next thing that we talk about here, trees and forests within Active Directory. So if we have a bunch of domains, we can actually link these domains together. So a domain tree is a collection of one or more domains or in a domain tree in a contiguous namespace linked in a transitive trust hierarchy. So what does that mean? Let's say I have the domain goldfish.com. Okay. I could make another domain that would be fishbowl.goldfish.com. And I could make another domain that is b.fishbowl.goldfish.com. These all are within the same namespace, and I'm just getting further defined the further that I go down. And then I could link these all together so that they could all interact with each other. This can be used in different organizations if you want to, instead of organizing a single domain by locations, you could potentially have multiple domains in different locations if you want them to be more self-managed instead of centrally managed. We also have what is called a domain forest, which is a collection of domain trees that share a common global catalog, directory schema, logical structure, and directory configuration. And the forest represents the security boundary within which users, computers, groups, and other objects are accessible. This became a big deal because we have company buyouts that happen in real life. Company A buys company B. Well, how do you get everybody at company B into company A? Well, if they had their own Active Directory, a lot of times, let's just kind of link our Active Directories up together, put a trust in between them, put them all in a forest. And if we can sync up our directory schema, then we can have them share back and forth with each other, and I don't have to create new user accounts for everybody. I don't have to switch what domain is managing them. We'll just kind of link up the domains and then be able to share user accounts, etc. that way. So that is where a domain forest comes into place. So here's just another picture of that. We have over here, we have domain trees. So let's say this is kelvin.edu. This domain here, I might have ad.kelvin.edu over here. I might have cs.kelvin.edu over here. These would all be trees off of a root common domain. But then I also have a forest here where this domain over here, kelvin.edu, might be linked up to hope.edu. I don't know why we would do that, but let's say we did. And we have a trust that allows items from this domain to talk to items in this domain, or in particular, this domain tree. So it can be used to kind of logically put things together, and these links between these are called trusts. So within a forest, so within an Active Directory forest here, this is all one big forest, multiple domains that are linked together. I have a couple of other operational roles, or those operation masters within a forest. I have a schema master, which is responsible for performing updates to the schema. And the schema master is the only domain controller that can perform write operations to a directory schema. And what I mean by schema is, let me see if I can show this again. All of these attributes that are set up here, they have to exist within a schema. So if I've made changes to my schema, I might have some attributes that another one does not have, or vice versa. Microsoft, for a long time, when they were deploying new software packages, they would make schema changes to Active Directory to support this. I'm thinking specifically the Outlook packages of the Outlook email servers. You had to do a schema extension in order to support that. Nowadays, if you want to do Outlook Online, you have to do a schema extension to support that as well. And there is one domain controller in that entire forest that deals with that. So that would be somewhere in here. It doesn't matter where. There will be one domain controller that is making sure that the schema for everybody is the same. I also have a domain naming master, which manages the addition and removal of all domains, regardless of the domain in the forest hierarchy. This kind of, yeah, just so if I want to add or remove something, some machine has to be authoritative for that. So I mentioned this already. The AD schema is the Active Directory component that defines all the objects and attributes that the directory service uses to store the data. Base AD has a base schema that corresponds to the AD functional level, and they update the functional level every couple of years as new versions of Windows Server comes out. One of the last things I want to talk about is the global catalog. The global catalog is my master list of everything that I have in my domain or in my forest. So my forest contains multiple domains and trusts. Sometimes I need to just say, okay, where do I search to find out everything. I don't want to search all the individual domain controllers. I want to search one central location that knows everything. So that global catalog will store all the all a full copy of all the objects in the directory for its host domain, and read-only copies of all the objects for all the other domains in the forest. And they respond to these global catalog queries. We might talk about this more later, but as Microsoft has moved stuff into the cloud, they implemented an extension of Active Directory into the cloud, and they originally named it Azure AD or AAD. It is a cloud implementation of Active Directory for Microsoft Azure services. It can be used standalone without having an on-site Active Directory, but I could also synchronize a directory in Azure Active Directory with an on-site local Active Directory. And it's needed for Azure services, especially with Office 365 services. Calvin synchronizes your user accounts between the on-campus Active Directory setup and Azure Active Directory setup, and there is a software package that synchronizes those two to keep passwords in sync and to keep user account information and who's an active user and who isn't an active user, all that stuff in sync all the time. A lot of times you will combine that with two-factor authentication. Kelvin uses the Duo system for two-factor authentication, but there are other password like authenticator apps that are out there that you can do as well. It was called Azure AD for many, many years, and then just about a year ago they said, oh, let's name this to something new, and they renamed it to Entrada ID, which I don't know why, and I don't understand why, and it's a terrible name as far as I'm concerned. But the big thing here to remember is that on-site Active Directory does not equal Azure Active Directory. They are two separate products. They perform similar functions, user accounts, authentication, authorization, but one is for the Azure environment, one is for the local domain that you might have. All right, servers and domains. It would be good for you to be able to join a Windows server to the Active Directory domain from the GUI and command line. And you'll be able to identify what changes about a local machine when that machine is joined to Active Directory. So domains are, we've talked about domains already. They're a logical group of network objects, computers, users, devices. But for our conversation here, the rest of the time, let's just say that a domain is an instance of Active Directory that's assigned to a particular fully qualified name, such as like ad.kelvin.edu. Have I used domains before? Yes, you probably have used domains. Calvin AD is CIT's Active Directory domain. You might see Calvin AD / whatever. If you're using Windows machines. CSAD is Computer Sciences AD instance, and you might have to log into CSAD in one of your labs in this class. But every computer also has its own local authentication that it can do. So it kind of has a local domain, which is going to be the name of your computer / or if you want to shorthand that, just / will get you to log into your own computer. And note here, your local computer isn't a full domain, but it kind of acts the same sort of way when you do a login. So in every single domain that I can have unique user instances with the same username. So on the screen here, there's 3 cweary39 usernames up there, Calvin AD / cweary39, CSAD, and /cweary39. These are 3 different Windows accounts. Each one could potentially log into the same Windows server, but they are still completely different and isolated Windows accounts from each other. They do not map on top of each other. When a computer or server is freshly installed, it's not going to belong to a domain. The process of linking it up with a domain is called joining a domain. And this requires that you have domain credentials that are granted the privilege to join a domain. How would I do that? In Windows Server, I could go to the Server Manager and Local Server, click the Workgroup tab, and change and make it a domain member. Or if I'm using Server Core, I have the sconfig thing that I can use as well. When a computer joins the domain, several changes are going to take place to the computer in question here. First, any authentication any authentication routine that happens after you join is no longer going to target the local computer. It's going to target the domain instead. Your firewall rules that you might have had on your local computer will get replaced with domain-specific firewall rules. Group policy, which is a way of managing configuration and security settings in Windows, will be applied to your machine, and any group policy that is set in the domain in Active Directory will be applied to your machine. And any DNS lookups that you have are going to go to your domain first. And those are the big ones that happen there. All right, standard configuration policies. How do you apply OS configuration standards to a lot of machines? As an administrator, if you're managing Windows machines and you're managing an Active Directory infrastructure, you want to be able to apply standard configurations to your machines. Built into Active Directory, there's something called group policies. On a local Windows machine, if you are not in a domain, you would have something called local security policies, which you could use to lock down certain features in Windows. You could use it for standalone computer management, imaging, etc. But if I'm in an Active Directory, I can use group policies in order to apply policies that need to be set on every single machine. These could be your company policies, these could be security policies, or this could just be configuration options so that you don't have people messing up their machines, which happens quite a bit if you let them play with things. Policies can coexist, but have a precedence that allows overriding of policies. The highest precedence wins, and that configuration will be enforced on the computer. So, if I have a local computer and I set up local group policy, that will apply. If there's nothing above that to override that, it will be applied to the machine, and that's what I'll end up with. However, if I'm in a domain and I have a GPO linked to a site, and remember, sites are a physical location, like an IP subnet in a physical location, then those are going to be applied next. If I have GPOs linked to an entire domain, that'll go it'll go next after that. And then lastly, if I link a GPO to the OU where my computer object resides, those will have the most highest precedence, and those are the ones that are going to win over everything else. So I could set one of my policies to something to like A here, to B here, to C here, and to D here, and it's going to be set to D because it's the GPO that is linked to the OU has the highest amount of precedence and will win out over everything else. So what can you do with local and group policies? Well, you can do lots of things. Commonly, it's used for things like user management, roles, firewall, rules, etc. I could copy and remove files on a PC. So let's say I wanted a couple of different files to be standardized on all machines. Let's say like a background image. I could push out a background image and then set that via group policy. I can actually install programs via group policy as well, especially if they're in the MSI file format, and so much more. And that's it for this slide deck. So we will get some more experience with using Active Directory and making users and playing with group policy in further labs and homeworks. Hope you enjoyed it, and let me know if you have any questions. Thanks. Bye.